Hello, my name is Don Metzger. This video is the third in a series of videos about the Analog Devices AD9084 being hosted by a Xilinx VCU118 host board running under Analog Devices IIO software. And this video focuses on the subject of multi-channel synchronization. If you want to see how to set up the VCU118 digital host board, I suggest you see the YouTube video AD9084 VCU118 IIO setup video. That'll help you get the system up and running. In this video, we'll show you the board setup that we're using. Then we'll show you how to set up quick MultiTransceiver. We're going to be using a 1 GHz chirp signal, and we'll use that to demonstrate the multi-channel synchronization capabilities of the AD9084. And then we'll end up by demonstrating the triggering firmware capabilities. Although we won't be able to do that with the 9084, we'll use another member of the MXFE family to show you those firmware capabilities. Here's the board setup that we're using. The board at the top is the VCU118 host board. The board at the bottom is the AD9084 eval board, and we've just looped each of the DAC outputs into ADC inputs. So we have 4 DAC outputs looped to 4 ADC inputs. We're going to use quick MultiTransceiver to show the multi-channel synchronization capabilities of the 9084 chip. On the MultiTransceiver software, first we select the connection. We're going to talk to a 9084 hosted by a VCU118 over the network at that IP address. For the particular settings of the 9084, we're going to capture 32,000 samples. We're going to select synchronize the numerically controlled oscillators. Each of our transmit channels is going to be at a different frequency, 2 gigahertz, 2.5, 3, 3.5. All of these transmit NCOs are all playing out at a different rate because we've entered a different center frequency. The associated receive channels will be aligned, so a 2 gigahertz for receiver 1, 2.5, 3, and 3.5 for the other receive channels. For a transmit waveform, we're going to use a chirp signal. So this is a 1 gigahertz chirp that happens in 4 microseconds, and then there's a 4 microsecond off to give us a pulse repetition interval of 8 microseconds. So let's go start an acquisition, transmit, and acquire session. Here we go. We've got 4 transmit channels operating and 4 receive channels operating. The center frequency for the channel 1 over here is 2, 2.5, 3, and 3.5. So everything's playing out at a different frequency. And we see that the captures are hopping around in time. This particular firmware that is in the 9084 eval board does not synchronize the captures of data with where the transmit waveform is in playing the transmit waveform. So it sort of runs open loop. It just acquires whenever we ask it to acquire, but there's no synchronization that's going on there. But you can see that the captures of each of these channels is all synchronized in time. All of the samples for the 4 channels are being kept timed precisely, and that's on the transmit side and on the receive side. To show the next level of synchronization, we're going to turn on the correlating receiver that is in quick MultiTransceiver. And we're going to correlate with that transmit chirp waveform. So let's turn that on. And I'm going to stop this for just a minute. And you can see that this correlation is peaking right at the time of the beginning of this chirp. If we look at the timing up here, that's about 5.22 microseconds, and that's where this is peaking down here, about 5.22, something in that ballpark. So each of these channels is peaking at the same time because the timing is correct. But I want you to notice the phase. Up here on the left-hand part of each of these correlations, we display the max value, and we're doing a linear value here, so 0.96 is the correlation coefficient. And then we present the phase value. And what I want you to notice while it's running is that the phase value is very stable in this. Even though the NCOs are all playing out at different frequencies, that the phase relationship between all of these channels is being kept the same. And that's due to the highly synchronized nature of not just the sample captures on the 9084, but also the synchronization of all those NCOs. If you're to do this in a traditional piece of test and measurement equipment where you're trying to use two pieces of equipment and synchronize them, you're not going to get this phase consistency. It would be difficult even to get the sample timing consistency between different channels, but all of that, because it's happening inside the 9084, is being kept in very tight synchronization. Another way to demonstrate the tight synchronization is to repeatedly start and stop the system. So I'm just going to start the system up and running, and you'll notice we get a number like minus 126.5 degrees. I'm going to stop it. I'm going to start it again. There we are, right there in the middle of the minus 126s for degrees. Stop it, start it again. And it always comes back to the same state. No matter how we start the system and stop it, it will always give us this same result. And because that result is consistent, now we can go in here and we can actually remove this amount of phase from the received received data. So I'm going to rotate some phase, positive 126.6 for this channel, and you will notice that we've removed that phase because it's always the same. I can start it, stop it as much as I want. It's always going to be the same, and so now we can remove it through a calibration step that measures it, and then we can remove it so that it's no longer part of our system. Why is there phase like this? Well, the cables from one DAC to another ADC are not all the same length. Also, we're at different frequencies, so there's a different amount of phase between those channels. So there's a lot of things that can cause that. But because it's consistent, we can calibrate it out. For the last demonstration, I'd like to show you some special firmware that Analog Devices is working on that synchronizes the acquisition of data with the transmit waveform. At the moment, I do not have this special firmware for the Apollo chip, the 9084. I only have it for the 9081. So in quick MultiTransceiver, we'll choose the 9081 with triggering. That indicates that it's running this special firmware. And then in the settings for the 9081, you'll notice that we have these 9081 with triggering. We have these controls where we can advance or retard the transmitter or the receiver waveforms. So we're just going to set this up to acquire 8,000 samples. Our transmitters are all going to be at different frequencies, 1 gigahertz, 1.25, 1.5, and 1.75. The receivers likewise will do at 1, 1.25, 1.5, and 1.75. And let's just start the system running. Again, we're going to be running a chirp signal in here, and so we're transmitting a chirp and capturing that, and you can immediately see that the captures are happening in relationship to the timing of the transmit waveform. So the chirp isn't hopping around in time in the capture, it's locked in place. And so this is a desirable characteristic, particularly if you're doing radar and things like that, that you get this timing so you don't have to go search for the waveform in the acquired data. I'm going to turn on the correlating receiver, and we'll run that so you can see the peak of the correlation here happening at the beginning of our chirp signal. And notice the stability of that correlation. These things are lock solid. They are not changing at all in phase relationship to each other. That was normal. We saw that with the 9084. But in this case, we've got all of these acquisitions now that are timed up just right. So this firmware, I understand from our friends at ADI, is going to be coming for the 9084. I just don't have access to it at this point. But I wanted to finish with this demonstration to show you what you can get and what will be coming for synchronizing to the next level, which is a waveform timing type of synchronization. All right, that's it for this video. For more information on the Quick MultiTransceiver software, you can visit our website at quicksystems.com or send us an email at sales@quicksystems.com. Have a good day.